Looks like we have some double replacement reactions here, also known as double displacement reactions. Let's write the reactions, let's write the equations and balance them. And for double displacement or double replacement reactions, you're often going to use these solubility rules that we're going to provide for you on your, or actually you're going to copy on your reference sheet for your test. All right, let's do A. Sodium hydroxide. Let's do A. Sodium hydroxide solution is NaOH, one positive, one negative, then they're going to cancel out, AQ. These are notorious for being reactions in solution, so they're all going to, oftentimes they'll all be aqueous except for the one precipitate. All right, and iron 3, that's iron with the 3 positive charged cation. Nitrate is NO3, okay, with a 1 negative charge. So when you crisscross these charges, right, so that 3 is going to go outside the nitrate, which is why I need a parenthesis. All right, maybe I should have written it smaller. Okay. No activity series to check in double replacement. You're simply switching the cations. All right, so let's just go with sodium is now going to be partnered up with nitrate, and that's just going to be NaNO3. That's aqueous. All nitrates are soluble. Check your solubility chart right there. All nitrates are soluble. So we can expect this other one to be the precipitate, iron hydroxide. All right, so iron is a 3 positive. It's going to go down like that, and that's going to be your precipitate. All right, hydroxides are generally insoluble, except for your two important ones that to know that are soluble are sodium hydroxide, which we'll use in the lab, and potassium hydroxide. But otherwise, they are generally insoluble. All right, let's balance this out. All right, sodium hydroxide. Write your polyatomic ions on one line because they're not going to change. I'm not going to write this little, sorry. Write a little bit smaller. Sodium hydroxide, iron, and nitrate. All right, in that same order, sodium hydroxide, iron, and nitrate. All right, got 1, got 1, got 1, got 3. For here on the right, 1, got 3, got 1, got 1. All right, sodiums are balanced. Let's balance the hydroxides. Go to the reactant side, multiply where you see. I'm going to pick a different off shade here so we can, let's go here. All right, go to hydroxide where you see hydroxide on the left, and let's put a coefficient of 3 there. Right, that's going to balance out the hydroxides, but don't forget to update the sodium. All right, so by balancing out the hydroxides, we unbalance the sodiums on the product side. This is often going to be the case, so we'll have to go to the product side, put a coefficient of 3 where you see the sodium. All right, and usually that does it. All right, that's going to also update the nitrate to what we want typically. All right, so there it is. 3, 1, 3, 1 are the coefficients. All right, let's go to B. Barium nitrate and phosphoric acid. Barium nitrate, phosphoric. All right, we're doing B. Check I might need that room, so I'm just gonna do. I already forgot what it was. Barium nitrate, phosphoric acid. So barium is a 2 positive charge, so I'm going to need a parentheses around this nitrate. Here, let me show you the charges. 2 positive, nitrates on 1 negative polyatomic ion, so crisscross those, and that's how I get the 2 out here. Right, all nitrates are soluble. All right, and phosphoric acid. Sorry, it's PO4. Acids are in solution of water, are aqueous solutions. And we're just going to switch the cations. All right, let's do barium first. All right, barium's now going to switch places where hydrogen was. So it's going to be barium with a phosphate. I'm going to need parentheses here, so I'll put that in now. Charges are not the same; they're not going to cancel out. So phosphate is a polyatomic ion with a 3 negative charge, and barium is in the second column of your periodic group 2. So it's a 2 positive charge. Did I say phosphate is a 3 negative is what I meant. 3 negative. So let's crisscross those numbers. So it's going to be Ba3 and then phosphate 2. All right, now phosphates are generally insoluble. So is barium is barium an exception? It is not. The only exceptions are ammonium and generally your alkali, your group 1 metals. So this is going to be your precipitate. All right, now the hydrogen, right? Did you bring that 3 over? Don't do that. Don't do that. All right, hydrogen is now going to be with the nitrate. Hydrogen is going to act as a cation, so it's a 1 positive charge. Let me put that on later. Nitrate is a 1 negative charge polyatomic ion, so they're going to cancel out. All nitrates are soluble. Nice, barely fit. All right, so let's balance this. All right, barium. Again, put your polyatomic ions all just in one line. And I'll put it in the same order so I can compare side to side, side by side. Right? Don't separate your polyatomic ions. You can see on both sides they're the same. Sorry, barium on the left I have 1, nitrate I have 2, 3 hydrogens and 1 phosphate. On the right, 3 bariums, 1 nitrate, 1 hydrogen, and 2 phosphates. Yeah, I don't even want to do this one. All right, let's start with barium. Times 3 on the left. All right, there's barium, so we're going to put 3 there. Update the nitrate, multiply that by 3 as well. So 6 nitrates on the left. All right, nitrate on the right. I'm going to put a 6, multiply that by 6. So where we see the nitrate, we need a coefficient of 6. All right, don't forget to update the hydrogen. Let's get that multiplied by 6. Got 6 there. All right, back to the left. Ping pong. All right, we have 3 times 2 is going to get us 6. So let's put a 2 where we see the hydrogen. That's right there. Don't forget to update the phosphate. Come on, baby, work out. Of course it's going to work out. All right, there it is. Coefficients are 3, 2, 1, and 6. All right, one more. Iron 2 sulfide. All right, that's not a polyatomic ion. That is not. Iron 2 sulfide. All right, I'm going to forget, so I'm just going to do that part first. Iron 2 sulfide. Sulfur is a 2 negative charge, and iron 2 is a 2 positive charge. They're going to cancel out. So, what was the other one? And hydrochloric acid. All right. Oh, sulfides are generally insoluble, so we'll put that in. Did it tell us? All right. Sulfides are generally insoluble, so that's solubility rule there for sulfides. Hydrochloric acid is aqueous HCl. All right, let's switch these cations. And let's put iron first. Iron is going to now be a chloride. Chlorides are, check your solubility rules there. They're generally soluble. This is iron 2 now, so that 2 positive is going to crisscross down there, so it's FeCl2. Let me do this a little better. And the hydrogen is going to end up with sulfur. Okay, so hydrogen is going to act as a cation here. Sulfur. This is not an ionic compound, so but you could do this. All right, bring that 2 down there. So this is not an ionic compound. It's going to be a gas. We would tell you that on the test. Yeah, these are not that very common. Most of the ones you'll see on our tests are going to be solid precipitates. 2 aqueous solutions and mixed, and one of them is a solid. Textbooks pick out some odd problems. It's good to see, I guess. All right, let's balance this. Iron, sulfur, no polyatomic ions. All right, in the same order. 1 iron, 1 sulfur, 1 hydrogen, 1 chlorine, 1, 1, 2, and 2. All right, well, the HCl is going to have a 2. There you go. We're done. There you go, to show you the work. All right, 1, 2, 1, 1.